All right, welcome back. We are GAME3001 in the summer 2022 semester at George Brown. It's week 9 of our broadcast and recording for our lab. Let's say part 1. We'll call it part 1. And for this week, we're talking about decision trees. We started a little bit late. Thank you for waiting. That's me, as normal. Thanks a lot. And this week we're talking about, in our lecture series, we're talking about decision making. We're also starting lab 6. That's where we're at. This half of semester is all around decision making and AI behavior. And like I tried to allude to in the game production class, I believe it's probably way harder than the first half. So if you struggle with the first half, the second half is going to be even more challenging. And I'm not trying to scare you guys, but it's just the way it is. So what I've done so far for you guys is I've released an assignment 3, 4, and 5. So assignment 3 is basically AI sensing, and that's why we're doing lab 6. Lab 6 is all around line of sight. That's kind of the beginning of it. And assignment 4 is built upon assignment 3. So 3 and 4 are kind of one, if you will. But I've broken it up into 2 pieces. The first part, which I'll talk about on Thursday, is just kind of your basic enemy behavior that we're going to be talking about. But today, the lab we're going to be doing today is all around line of sight. How do I get line of sight? How do I make a grid of path nodes and all that kind of stuff? So there's also assignment 5, which is your final presentations, and you can see that the last half of semester is pretty hefty in terms of assignments. Okay, and each lab is worth at least 4%. This lab 6, is a combined total of 8%, so it's almost like a mini assignment that you're going to see. So last time you were together with Alex, you kind of focused on pathfinding, and A-star pathfinding was the main thing. You also talked about other heuristics like Dijkstra's algorithm. I think he went through Dijkstra's with you as well, and he did 2 types of heuristics. He probably did Manhattan distance and a Euclidean distance, which is what we talked about. Lab 5 was all around finding the shortest path, and then the feedback that we got for A2 when I talked to Alex was that still pathfinding was kind of wang when it came to how to make it work properly. That's kind of the major feedback that he kind of had. This week, what we're talking about is decision making and decision trees, what those are. And one of the challenges that make the second half of semester very challenging more than the first half is the fact that we're talking about data structures. So if I say, okay, you're going to code in C++ and you have if statements and for loops, hey, right? But if I say you're going to make a tree, then you're going to be like, ooh, that's like more difficult. And you're going to be using a tree structure, and it's going to be basically that allows you to kind of navigate from one node of the tree to the next, right? And we'll talk about that on Thursday. I'm not going to waste your time today with that. We're already behind the 8 ball. So like I said, I've released assignment 3, 4, and 5. Please join if you can. If it's for groups of up to 3 members, the A345 group set. Okay, so you can do it with 2, you can do it alone, or you can do it with up to 3 people. Okay, so that's what's happening right there. So if you already have somebody you're very comfortable with, most likely you guys are already in groups here, my guess, then you might as well stay with those groups and just re-sign up for groups A3, 4, 5, or else you will not be able to see your assignment 3, 4, and 5. Okay, so please do that as soon as you can. Okay, so that's what the day is. I'll be going through the rest of this PowerPoint slide deck, which has got another 50 slides or so on Thursday, and then we'll go through it together, and it's kind of all around decision making. But for today, what I want you guys to do is let's go up on Blackboard and download the Lab 6 starter. You guys have done that, and you're encountering some issues. I'll do the same thing. So I have kind of the Lab 6 starter here that I've already got. So this is let's enter lab. Here's my starter, right? And I'm just going to grab this starter, copy it, and I'm just going to go out to my desktop, and I'm going to make a brand new folder for just you guys, right? So a new folder. We're going to call this Game 3001. And you guys, are you guys section 1 or section 2?
2.
Are you section 2?
Yeah, I think so. I'm not sure.
Okay, section 2. We'll just call it section 2. Whether you are or not, doesn't matter, right? All right, and then I'll just paste that in. So there's our lab 6R. This is what you should do too, right? So when I extract that, let's extract, then it's going to take us here. And I don't need this zip archive anymore. I can get rid of it, delete. And you guys have some issues, and I know what the issues are. Let's go through those issues now. First, if you're working with the machine in front of you, anyone working with the machine in front of you? Like the lab machine? Good. That would be the first problem. And I'm just going to close this off for a second. Let's just close all these tabs. So if you're not working with a machine in front of you, are you running 2022? Yeah. All of you? Good. So then you'll get the same errors as me. So the first error you're going to get is a bunch of errors that say you've got this stuff there, because what we did was we took Alex's old Lab 5, and what we've done is we've modified it, as an example, to make Lab 6. So when I build it, I'm going to get the same build errors as you. Let's go through them. And I'll talk about how to fix those problems. Basically, what they are is there's a bunch of extra files we don't need anymore, and we're going to remove them. More or less, that's what it is. So, and as I'm finishing the build process, you can see that I'm down here. It's building, building, building. And one day my machine is going to finish. As an aside, well, this is happening. So Philip in Game Production 2 next week is not on site, correct?
Yeah.
I am not going to be on site if he's not on site. Why would you wait for me to come at this time from 3 to 5, right, as an example, when this is the only period you have for 2 hours? You're going to travel an hour to get here for 2 hours. Again, I don't agree with that. So what we're going to do is next week we'll host everything online, okay? And this one will make it easier for you guys. All right, so it says, look, here's the issue. Path Manager, tiled.cpp, and tiled level. Let's get rid of all those files. Path Manager, tile, and tiled level. So again, if I go to Solution Explorer, and if I go to pathfinding, I don't need the, under managers, I can get rid of Path Manager. So when I say get rid of, highlight both the CPP and the .h, right click, and then go to remove. And remove won't delete it, it just will take it out of your project, right? The other one is under game objects, under the tile.h and tile.cpp, we can remove those as well. Let's remove, as well as let's remove the tiled level.h and .cpp. Those things can all be removed. And if we do those things, nice, then we should be able to run it again and it should work. Now, the other thing that people got was that somehow or another, the stuff online on Blackboard, for whatever reason, they had issues with Sound Manager. If you're one of those people, it's because for whatever reason, Sound Manager.cpp has been removed from Blackboard. I zipped it up, so I'm not sure why it would be removed, but it was removed by accident. If this is you, if your Sound Manager doesn't exist in your list, you need to add it in again. All right, otherwise it'll give you linker errors. So hopefully you don't have linker errors. I'm just rebuilding like you, so we should be up and running in a second. And you should see this. Are you there? Abu, you're good? Smarco?
I'm getting there right now.
We got one error, Pathnode.
Yeah, we gotta get rid of those.
Yeah, so yeah, you can delete Pathnode.
The H is not CP. Both.
Yeah. Pathnode? Is that what you were asked to do?
Yeah.
No, Pathnode you need to keep.
Oh.
Pathnode you need to keep. But Pathnode,
You can just add that, but it's Pathnode.
yeah. All right, so let's look at so the list also includes this little to-do list, this little step-by-step that we usually do. And the first thing we did was we started a starter project and we made it work. Okay, that's the first thing we did, right? So now we're going to do our first commit. So let's do that. You can use your commit like you normally do. One thing I need you to do on your GitHub repository is please include me as a collaborator. So that's my last name only at hotmail.com. Okay, if you don't include my last name at hotmail.com, you will not find me as a collaborator. It'll be somebody else. Okay, so please do that. So let's add this into GitHub, and I'm going to use command line for this. So here's my command prompt. So you can see it a little differently than you have in the past. I know that I'm working with my, I've got the stuff up on my desktop. Here's my desktop. And here's GAME3001 section 2, and there's my lab 6 starter. What I want to do is, if I kept it lab 6 starter, I want to close off my Visual Studio altogether. And I'm going to change this lab 6 starter. I'm going to rename it to lab 6.1 for me. You can keep it as lab 6. The reason why I'm calling it lab 6.1, maybe it won't work anymore because of my craziness. Just 1 second, I'll make it work. 1 sec. What Visual Studio does is it reserves the last project so you can reopen it again. And that's why it's not letting me rename. I'm just going to stop that in a second by just doing a trick. There we go. And that should work now. So yeah. So you should call it something like lab 6, because I'm calling it lab 6.1 because I'm going to give you lab 6.1 complete next week as a starter, just in case and it's not liking me what I'm doing. That's fine. That's fine. I'm not sure why it's doing that. Maybe it's OneDrive. No. It's so funky. It's so funky when this happens. Because I can't rename it at all. Let's see. Yep. Because the folder files open in another. Yeah, I've done it. I've done it in the past as well. I've just normally, if I open up another project, it's okay. But maybe it's because something's running or whatever. Anyway, the idea is you're supposed to rename it to lab 6.1 or 6 for me, for you. Let's try that again. Let's close this off, and let's just let me just wait for it to start, and I'll run it, and then I'll close it off again. Yep. Because that's the first one. The first one is just like your files, right? You wanted to start off with your base. And then from there, what we're going to do is we're going to add more stuff to it. One day when it feels like it. And it's taking its sweet time, which is, it should be like starting like that, because for the most part, we haven't really done anything different than we did already. Okay. One more time, and if it doesn't work, I'll just put it up with that the way it is. Okay? I'm not going to go too crazy. And sometimes it could be because I have a window open somewhere or whatever that is looking at it, and that's fine too. Let's try this one more time. It's a system issue. I'm sure it's not going to work. Yeah. Okay. Let's just put it up like this. So what I normally would do is this: if I want to put it up on GitHub with GitHub commands or Git commands here locally, then I want to put this whole folder over there. So what I'm going to do is I'm going to do a CD space, drag and drop the folder in there, and then start from there. So then I'm going to say a git init. And what git init is going to do is going to add this whole section to the repository. If I do a dir, you can see that I have my lab 6 starter. That's what's there. And I can do a git add dot. Git add dot adds everything to the repository. There it is. And then I can do a git commit minus m, and I'll say initial commit. And that basically is the first part of getting my lab 6 going. Now I need online, I need a repository that I can use. For the previous class, I just used GAME3001 M22 labs. We'll just call this M22 labs section 2. So we'll do the same thing, make a brand new repository online, right? And we'll say GAME3001 in the summer 2022 semester, labs for section 2. And I'll make it public, and then I'll press enter. And this gives me steering instructions online on how to connect. I'm just going to grab these last 3 lines of code here copy them. You don't have to do any of this stuff because you're using GitHub Desktop. And if I press enter, it's going to push it up on GitHub, like so. So that's the back-end commands. Right now, you guys are using a tool, that's great. But one day, you should be learning console commands. And if you do, you can fix some of the errors that you might get where your tool can't help you. Okay, or not as easily. Refresh. So now that I'm here, you can see that I've got my Lab 6 starter. Not exactly what I wanted, but it's okay. And let's get back to what I was doing before. So back into here, let's get moving on what we want to do. So in the template, we've done this piece already, and we've done our first commit. This is our first commit right here. It says here in the Starship.cpp in the constructor, we're going to add lines for the heading, direction, line of sight, color, and so on. And this is something we want to do. In the draw, we also want to add a line for the line of sight, and we have to make sure that the Starship works the way it's supposed to go. So that's kind of our first job. So I'm going to go into my Solution Explorer, and I'm going to go to Game Objects where I have my Starship, and I want to go to Starship.cpp. It's the first change we're going to make. Let's do this together. So here we can see that sight distance is 300, and I'm just going to pull up my changes here. And I'm using some paper notes, which is an unusual thing for me. I never use paper for anything that I do. But, you know, we're remote, and we're in person right now. Normally I'm remote. All right, so here in where it says line of sight distance, instead of 300, let's set the line of sight distance to 400. So this is in pixels. So we want to say that this is our range. This is how far. So again, if I was going to shoot a ray at Abu over here, and let's say, what do you think the distance is in actual meters between me and you, Abu? What's your estimate? By the way, humans are terrible at these things, but let's suppose. 5 meters? That's 25 feet? You think it's 25 feet away? Or, sorry, did I say 5? 15 feet? I'll be okay. 15 feet? Is this 15 feet? I think it's longer than 15 feet, right? So I would probably say, you know, it's probably like 20 feet, let's just say. So let's say it was only, let's say my line of sight range or my distance is 15 feet. Even though I can see you, I'm out of range, which means I don't have a line of sight. That's another condition. There's 2 conditions for line of sight. If I can't see you because you're being occluded, blocked by something in between, or if you're too far away. Those are the 2 options. Okay, so my line of sight distance is 400 in pixels. The next thing is my line of sight color. We want to set that next. So down here, we're going to say, let's set our line of sight color. There it is. And we'll set the line of sight color to a GLM vec4 object. Vec4 is a vector 4 instead of a vector 2. That means it has 4 components. And we'll set it to 1, 0, 0, 1, which is by default red, right? Default line of sight color is red. Okay, so that's the red color. And the last thing we want to do is we want to change our agent, our type from a, instead of it being a starship, sure, it's a starship, but we want to kind of identify our ship as an agent. So let's do that next. Let's change our type to an agent. So we're just going to type in agent there. Okay, and those are the changes we want to make to the ship. So that's the first part. That's the constructor function that we're changing. Okay? That's part 1. Part 2, now that we've got the constructor changed and we've set up our type, which is an agent, our line of sight color, which is red by default, and our line of sight distance, which is 400, in the draw function, we want to actually draw the line of sight. Let's do that. So we want to draw line of sight, right? And how do we do that? We're going to draw a line. So we're going to use the util method, the util class, right? We're going to say, hey, util, I want to draw a line. We've given you, Alex and I have given you a bunch of utilities, right? And to draw lines in different shapes. And this is the first thing we're going to do. So the line draw thing is going to be, we're going to start, notice when we do a draw line has a bunch of things. We need the start for the line. The start for the line is going to be the ship itself. So we're going to say let's get transform dot position. That's the start of the line. And we're going to go to the end. What's the end that we're going to draw? So we're going to say, well, we're going to say get transform dot position, plus we're going to add the current direction, or so get current direction. So current direction is like where we're pointing. Where are we pointing right now? And then multiply that by the line of sight distance. So get line of sight distance. There we go. And this will generate a line between the ship and where it's looking for whatever the distance is. In this case, 400 pixels. Make sense? I'm just gonna put this on 2 lines so you can see it lights up. How's that? Okay. Let's test it. Let's see if this actually draws a ship with a line that comes out of it. So if I run it, then we're going to see that the ship should draw now with a line that comes out of it, if we did everything correct. And it should be a green line by default. There's the green line. Okay. So that's weird. Why did it draw with a green line, but I told it to draw with a red line? How's that the way it's supposed to be? By the way, also, if I change my direction, it also changed the direction of the line, because wherever it's looking is the vector that I'm adding into its position for where the endpoint is, right? Okay, this is good. So why then is the color wrong?
For whatever reason, when I change that, now my ship is like at the top of the window.
Well, it's 0.
Oh.
There we go. All right, so that's cool. So now the thing is, because draw line also has another parameter. By default, if you don't specify the color, it makes it green all the time. So we have to add another parameter, which is get line of sight color. And get line of sight color will actually allow us to draw the color whatever we want. In this case, every round, by default, it's going to be the red color. So let's run it again. And we should, with that extra parameter that we just put in there, have our line of sight color being red. And there it is. But there's another problem. The problem is that it seems to me that the line is going underneath the obstacles. Why is that? Sorry? What do I mean? Yeah, take a look. You can see how the line runs underneath the obstacle. Right now, the way I have it situated, yeah, go ahead.
In the actual scene, is the object or the obstacle being rendered before the alignment, or it's called?
You mean it's
Or after, I guess.
well, it's being rendered. You're correct. You're on the right track. So what it is, let me show you. So if we go back to the Solution Explorer, and if I go down to the scenes, and if I go down to playscene.cpp, rendering happens in the draw function, right? So see this draw function up here? That's where rendering happens, but we can also see that it's just drawing the display list. The display list is formed by, if I go to the start function, let's go to just jump to the start function here. And if you notice, the way I'm adding things in, it's displaying them in added order. So the order that I'm adding things in, that's the way it's displaying it. But I don't have to accept that. What I can do is, instead of changing the order that I've added them in, I can just change the layer that I'm adding it into. So add child actually has an extra little bit of information you can add in. So the Starship, instead of adding it into the 0th layer, I can just select another number like 2, like this. And if I put 2 in there, it changes the layer index of the Starship, and because the line of sight is tied to the Starship, so too is that going to draw on layer 2. And if I do that, and if I run it now, you'll see it's very hard because, unfortunately, the Starship, the red line is also, the obstacle is red. But you can see that if I bring up the ship here, you can see that it draws on top of the target, right? So it's not below the target anymore, right? And it's actually on top of this obstacle. The reason why it's showing it this way is because the obstacle is also red. So that's how it's hard to see. Okay? Now there's some issues here. Okay, a couple things that we have to notice. A couple things. One is the ship, small as it is, right? As an example, the line of sight is coming from its center, wherever that the center of the ship is. Notice that the center of the ship is actually near the back of the hull, the back of that little circle there, right? That is the dead center of the ship. And if we want that line of sight to be drawn in the front of the ship, we just have to take half of its width and move that to the starting point, right? So if I was to do that, if I wanted to change the line of sight so it doesn't start in the middle of the ship, then I can do that by moving the line when I'm drawing it. So the way to do that is going back to the ship for a second. I didn't do this for the other class, but I'll do it for you. Is if you go to the game objects, and if I go to the Starship, here's the Starship Cpp again. Remember what I'm doing is I'm drawing the line from the Starship's position. But if I just add in, plus the current direction, if I say plus my get current direction, so that's the current direction, right? And then I multiply it by something like half of its width. So get width, multiply by something like 0.5, right? If I was to do this, so the ship's position, just like I've done this, so the start is the ship's position, and then the get, plus I'm adding get current direction multiplied by some width, right? So why would this not work? Why is this causing us to have an issue? But it was working down here, right? So why is this different? Well, if I hover over the star, it says, sometimes, by the way, it's a Visual Studio issue, right? Probably is a Visual Studio issue. Let's try it again. No, it's not. Okay. What's the problem? It says no operator stuff matches operands. Get width. Get width is going to be an integer multiplied by 0.5. Get current direction, which is a vector 2. We just did that over here. Look.
Would it be Starship dot get width?
No, because this is the Starship itself. We're in the Starship. Float. And then multiply by this. Let's do this. Just want to see something. Multiply by. That works. Yeah, because get width is an integer. I think I have to convert it to static cast. Let's see. I don't think this is the problem, but it's weird that it would give me that issue. Yeah, well, that's it. So when I do it now, it's going to be just half the width away in its direction. So that's where the start is going to be. Let's see if that works, if I'm right. And you can see now it's kind of in front of the ship, not on top of the ship. See it? And the way to check this is if I move this around now, you can see it's kind of in the front. It's not overlapping with the ship itself. Okay, so that is the ship. Let's put this up on GitHub. So again, I'm going to go back to here, and I'm going to clear. You guys can do it with your tool. I'm going to say git add dot, git commit -m, and we'll say modified spaceship or Starship to emit line of sight. Git push, done. So you can see how faster it is than using the tool, like really quick split kind of thing, compared to using a tool. I like using console, it's fast, but you may not like it if, as an example, it doesn't make sense for you. Let's go with the next part. So if I follow the instructions, so the first part we did is the Starship. The next one is the Pathnode.h and .cpp class. So Pathnode, I want to point out, is we modified it. So if I go back to Solution Explorer, and if I go to Pathnode, that's inside of pathfinding. Here's Pathnode. This is not the Pathnode that Alex gave you. This is a new Pathnode that I made. So I kind of replaced the Pathnode class with my own, right? It was an earlier version actually. And if I go to pathnode.cpp, you can see that the Pathnode is kind of empty. Okay? So this is the next thing we have to fix. And in order for us to fix this part, okay? And I'm also going to set the rigid body. Here's my rigid body. I want to set that up to is colliding is false, because we're not going to make it collide with anything. I'm also going to set the game object type, so set type. I'm going to set it to, if you press Control space, it'll give you a list of things. I want to call it a path node. There's the path node. That's important, an important step. I also want to set the current heading, because this is because it's an agent. I want to set the current heading to 0, 0, which is kind of an angle of where it's pointing, and I want to set the current direction of each. This is just kind of initializing each node when I create it to so that it points in the right direction. Okay, so right now by default each node points right. So by default, so faces right. And now this is the important part. I want to set my line of sight distance for each of the nodes. So if I remember, the ship has only a line of sight distance of 400, but my node has 1,000, which means I can pretty much see everything on the screen. And I also want to set my line of sight color. I want to set my line of sight color to a GLM Vec4, which is 0, 0.5, 1, and 1, which is a light blue. Okay? So that is my constructor for the path node. And then I want to draw the path node in the draw function. And we're going to use the util class. Let's include it up here. I'm going to include util.h. Okay. And the draw function is going to look like this. I want to util, and I want to draw a rect. Draw a rect. There it is. And when I draw rect, I want to get transform dot position. That's where the rectangle is going to be, the top left corner of the rectangle. And minus, because each of my objects are centered, right? Then I want to march back half its width and half its height. So in order for me to do that, I'm going to subtract a GLM Vec2. We know it's 5, 5. So that is what I'm going to march back. That is half the width and half the height. And then I'm going to put in the width and height here for the size of my rectangle, which is just 10 and 10. We can also calculate it by get width and get height. And also the get line of sight color, which is what I want to put in here. All right, so this is going to make it exactly, it's going to draw a little square, right? Every time the draw function is called. This little blue square. Does that make sense? Abu, are you with me? Is it? What was that? Okay. All right, so now one thing we should always do when we always make these changes, even though we can't see anything, is just let's run it, and hopefully there's no errors. The first thing we want to do is let's run it, and we can't really test the path nodes yet, but we know that the path node class has been modified, and as long as we can see what we saw before, we're good to go. We're good to go. Let's put this up on GitHub again as another commit. So I'm going to say git add dot git commit -m, and we'll say modified path node class to draw a small square, which is what we did, right? And git push. There we go. All right, so so now we've kind of done this piece. So this part is done. And this is where most of the work was spent. During the last class, I did all this. There's a lot of stuff to modify and do. Part of it is there is a bunch of functions to fill in, and we'll talk about which ones to fill in, which ones to remove. Okay? So let's do that now. Let's do this next part. So back to the, I'm going to close off pathnode.h and pathnode.cpp. And I'm also going to close off starship.cpp because I don't need that anymore. And I want to go back to my placing.h. Let's go back to my placing.h for a second. So one thing to placing, I said, not pathnode. Placing.h, there we go. So one thing to note is that how I added things in. If you look at the placing now, here I've added in a target, like before. That's the blue circle, right? I added in my starship pointer, and then I added this vector of obstacles. So question for you guys, what is a vector? Interview question. Yes?
It holds up to 10 arrays.
10?
Or only amount of arrays.
Okay, you got the array right, yeah? You're close. I want you to always think of a vector as a container. So a vector is like an empty container. It's, in many ways, on the back end, a managed array. In your mind, it's a managed array. It's a dynamic array, right? So I can add in as many things that I want, right? And we have to tell it the type because it's a template type, right? These are standard template collections, right? Which is the STL. In the STL, the standard template library, we have. That's why we have standard in front of here, a bunch of collections, and vector is one of them. Vector is a generic, which we have to, in the angle brackets, we have to tell it the type of collections, the type of objects in the collection. In this case, it's all obstacle pointer objects that are in the collection. So when I say obstacles, it's a collection of obstacle pointers that are in that vector, okay? And then we have something called build obstacle pool. And this is a very simple function. Whenever we create a vector, every vector is empty. It's like an empty box. We need to fill it in order for it to have anything inside of it. Just because I make a vector of obstacles, it doesn't include anything yet. We have to add obstacles to it by using the pushback method. So let's go into the obstacle pool. I'm going to right click on build obstacle pool here and go to definition. Here it is. And you can see that in go to definition, we've added we kind of do a for loop. And we're going to say m underscore obstacles pushback, and we're going to push back an anonymous obstacle pointer. We know it's an obstacle pointer because of the new keyword. The new keyword signifies we're adding a pointer and not an object. And pointers are great because they get added on the heap, not on the stack. The heap has much more memory. Stack is pretty small. And so we want to take advantage of kind of better memory management, and that's why we use these raw pointers. Okay, so we pushed it on. That's how we build. We built 3 obstacles. We put 3 obstacles inside of the obstacle array, managed array, a vector. I'm just going to go back here. So that's what we did with build obstacle pool. Okay. Now we have a bunch of additional functions that I added in. I want you to remove. I don't know why I add this in, but please remove store obstacles. Get rid of this one. Okay. Get rid of store obstacles. And that means that inside of the CPP file, we want to remove that function too. That's an empty function we don't need. There we go. All right, awesome. So now that we've done that, we have these functions to fill in. First, I want to build a grid, okay? We have a grid. Take a look here. I have a grid that I defined of path nodes. Here's my grid of path nodes. But just like the grid of obstacles, unless I do something with it, it's an empty box. There's nothing inside of it right now. I want to load up my grid with path nodes. Similar to what we saw with Alex, where Alex did a bunch of tiles, I'm going to create these little dots all over the place that represent points in space in our game. Okay? So in order for me to do that, I need to go to build grid. Let's go fill in that build grid function. Go to definition. I'm just going to reference my notes here. So in the build grid function, right, as an example, what we want to do, so make sure that there's nothing here that I need. I don't think so. Okay. By the way, I really hate paper. I have to mention that again because it's just like, it's not my favorite thing at all. All right, here's build grid. So first is what we're going to do with it. When we think about a grid, we want to understand the tile size. So I want to say const auto tile size, right? And the tile size is going to be config. We're going to use the config class, and we're going to use tile size. Now, Alex should have done something similar with you guys when we set up the tile size. Tile sizes are 40 pixels by 40 pixels. That's the tile size. The other thing we also want is an offset. Remember we said before that the offset is a GLM vec2 that we're going to basically subtract because all tiles are centered, and if I want to draw a tile, the actual box, the left corner outside of the center, because remember what we do is as soon as we draw anything, we draw from the center onwards. If I want to draw the corner away from the center, then I have to march back and then draw up there. Otherwise, you'll start drawing from the center of the object. That's not what we want. We want the little square to be, as an example, in the right position. So we're going to march back to do that. And the way we're going to do that is in the vec2, we're going to say the config, hey config. We're going to say that we're going to take the tile size, right, and we're going to multiply it by 0.5. So the reason why we're doing this and not hard coding it is because what if tomorrow we wanted a tile size that was 32 by 32 or 16 by 16 or some other tile size, right? So that's why we want to not hard code the tile size here. Okay, and we don't have this yet, but I'm going to put it up here. Every time we move stuff, we're going to call m_clear nodes. But clear nodes, you can clearly see right here, is not a function that has anything inside of it. Look, here's clear nodes. So I'm just going to comment this out for now until we define it. But that's kind of what we want to do. We want to clear nodes because we will need to clear nodes every time we move an obstacle around. So here's what I want to do with my obstacles. Okay, I want to point this out too. I don't want the nodes, the blue nodes, to be shown overlaid on top of my obstacles. If my obstacle is on top of a node, it should not show the node. The node should be not even there. In other words, I shouldn't even have a choice. There is no line of sight inside of my obstacle itself, right? Because each of these nodes is going to help me with line of sight in the end. Almost like rake casting, primitive rake casting, okay? Okay, so we're going to clear the nodes when we move stuff. But for now, what we want to do is we want to lay out a grid of path nodes And the way to do that is to start off with a for loop. So I'm going to do a for loop. And we're going to start off with two for loops. It's going to start off row first. So primary row. And we're going to use the config row num. By the way, the row number I think is 15. I think it's 15 by 20, the grid that you guys are dealing with, that Alex kind of made for you too. So that's kind of the initial outside. And then what we want to do is on the inside, we also want to have another for loop. So there's kind of a nested for loop that we're going to have. So this is the column for loop. And this is going to go from config column num. Right, this one. Okay? What we're going to do is we're going to make a temporary path node. So we're going to make a path node pointer. We're going to call it Pathnode. And the path node that we're adding is going to be a new path node. There it is. Okay. We're also going to say that the path node get transform dot position, right, is going to start off with a glm vec2. And this is a bit of a calculation we're going to make where we say that the column, whatever the column is, multiplied by the tile size, right, plus my offset is my x-axis. Okay? And for the y, it's going to be the row, right, in this case, which is kind of counterintuitive, multiplied by the tile size, and then plus the offset. By the way, it can't be offset. It's got to be offset.y and offset.x, and that's going to complete it. There we go. It's crapping up? Give it a sec. And we get these little funky little things here, like these little the underscores. And the underscores basically tell us, hey, by the way, there's things you can do to convert this to make this better. So if it's complaining, it's because we're trying to cast from an integer to a float. And so what we can do is to save this, we can take away this bracket, put it around the column for a second. Here, follow me for a second so you can see this. I'll do the same thing for the row. So take away the column, put it here. And then I want to static cast this part. So I want to say static cast as a float this piece. And you can see that that kind of takes away that issue because I'm not converting. When I multiply, it wants a float to, to multiply by tile size. One of them has to be a float, okay, for it not to complain. And I'm going to do the same thing with row. Okay, you can see that that takes away the errors. That's our position. And that position is going to be based on when I count through. So for example, I'm going for every row is the y, right? I want you to think about it. I know it's counterintuitive, the name, but columns are the x, right? That's the x, okay? So I start off with the first row, which is the top row, okay? And then I sit there and go, okay, the top row is 0, right? So that's a 0. 0 multiplied by something is always 0. So all we're doing is we're adding the offset for the first one. And then if it goes to 1, we're going to take 1 times the tile size, which is 40, and we'll keep on adding it across as we go. So that's how this thing works. Okay, so that draws the object, but we also want to know if we want to keep it or not. Okay? So in order for us to know if we want to keep this path node or not, what we kind of took care of is this thing here. We want to make a Boolean, which is keep node. By default, let's set it to true. So we'll say by default, we're going to keep it, okay? But we're going to do some checks. We're going to say we're going to do another for each loop. For each m_p obstacles, wow. For each obstacle in obstacles, right? For each obstacle in the obstacles array, right, that we just made, what we need to do is basically say something like, okay, I want to determine, right, which path nodes right, are inside the obstacles. Right, because remember we draw the grid and then we have an obstacle, and the obstacle's kind of hanging out on top of the path node. So to determine that, I'm going to do an if statement. I'm going to say if, and I'm going to use the collision manager. Hey, collision manager, I want to do an AABB check, and I want to pass in path node, the path node that I'm looking at right now, with my obstacle that I'm cycling through, and that's pretty much what I want to do. So do I have a collision between these two things? If I do, if there's a collision, then I want to say that keep node is equal to false if I have a collision. So what I'm doing is I'm doing an overlap. Does my obstacle, that red box that I showed you earlier, does it overlap with any one of the nodes that we have in the list? And if it does, don't show it, right? Else, okay, so keep node is equal to false. How about if I do want to keep it? If keep node. If I am keeping it, then what I want to do is I want to add child my node. And what I want to do is I want to also add it to the grid so we can keep track of it. Sam_grid, right? Dot pushback, and I'm going to add in the path node. So I have a grid as well. Okay, so I'm just not adding it randomly to the list. I'm also adding it to a grid. What up if I'm not keeping it? If I'm not keeping it, then I want to delete it. So I want to delete the path node. Okay. And that, my friends, is the first part of my build grid, right? So I'm eating it, I'm adding it, and so on. One thing to note is that when I come down to this point, so below this one right here, and that means that's it's got to be outside of the for loops. Okay, that means out here. Okay. So here's my for loop. You can see that it ends right here. Outside of the for loop, what I want to say is only display the grid if it is toggled on. Oh. Okay, and the way you can do that is if m_toggle grid, that's a function that we're going to call. And we're going to pass in if is grid enabled. So where did that come from? Is grid enabled? Well, that's just a value as an example that we're going to set later on. Toggle grid, this toggle grid function is not defined yet. It's right here, right? So notice it's empty right now. That's going to help us toggle the grid on and off. Okay. So that's the complete function. The only thing that we've commented out is this part, this clear nodes piece, right? We're going to put that back in a second. All right, let's keep going. Let's finish the toggle grid part. So toggle grid is going to be a for loop for each. And we're going to say for each m_p grid, for each node, path node, right? So path node. For each path node in the grid, what do I want to do? I'm going to say that the path node set visible to whatever the state is. And the reason why I'm saying that is I should be able to toggle the thing on and off. Set visible is a property of all display objects where I can set them visible or invisible. Okay? Here, where it says state, ReSharper is telling me this should be const. So let's just go here to this little funky light bulb and change this to const. Okay? So that's save. That's toggle grid. Next, let's fix up this clear nodes piece right here. Clear nodes is kind of a smaller function that we want to fix up. Okay? So clear nodes is interesting because it's pretty quick to get done, right? I'm gonna do check ship line of sight last. So it's gonna be m_p grid, right? Clear. We're gonna use the clear method because grid is a vector. Clear removes all the objects from the grid. And then I wanna say is for each, here's my for each loop. For each, and I'm gonna look at the scene's display list. So I'm gonna say get display list. Wow, my shortcuts are not working. Get display list, and this will be for every display object. For every display object in the display list, right? What do we want to do? If my display object, if that the type of it, if the type of the display object is equal to, and I press Control Space to put up a list to Pathnode, if it's a Pathnode, right? Then what do I want to do? I want to remove it. Remove child, the display object. So it's kind of a way of me going through the display list that's inside of the scene and removing all the path nodes. That's what clear nodes does. Okay, now that I have clear nodes, I can uncomment this piece up here. Okay, clear nodes. Is this good enough? Here's clear nodes again. Okay, awesome. So that before we do check line of sight, I want to actually see the grid. So in order for me to see the grid, let's make it go, and we'll do that inside of the in the play scene itself. Okay, I got to check with you guys. Are you with me? Are you good so far? Okay, let's do that. Let's just jump to the start function. Here's my start function, right? And in the start function, so far what I've got is, I've got the target, I've got the starship, I've got my obstacle pool with all the obstacles that I set up. And before I do preloading of sounds down here, before I do this part, I want to configure my grid. Let's set up the grid. Okay? So I'm going to say is grid enabled, and I'm going to say by default it's not going to be enabled, false. Okay, by default the grid is not going to be enabled. Am I going too fast? Should I slow down?
I'm just writing out one more thing. I'm just adding a little bit of child.
No problem. And then m_build grid is what I want to do next. So first I make the grid disabled, then I build it, right? I only want to show it if I go to IMGUI and check it on. Right, that's what I want to do. And I'll show you where that's done in IMGUI. And then I'm going to say m_toggle grid. I'm going to pass in m_is grid enabled, which should be false by default. So that's the only thing I need here in my start function to make it go. But we're going to have issues, and I'll talk about these issues in a second. It's only these three lines right here, right? So how does this work? I mean, where is it being checked on? Well, if you look down here in the GUI function, what I've done for you is I have a couple of things here. I have a checkbox, and that checkbox toggles it on or off. That's what it does. That's where it is in the checkbox. It's already there for you in the IMGUI function. So if I run this thing, let's take a look at how it works. If I run it, then I should see, when I check on it, a grid of tiles, but we're going to have a problem, and I want you to help me with it. Let's talk about the problem that I'm going to have. And there's a couple of solutions. All right. Oh, okay, so that failed. Did it?
Yeah, it's just off center a little bit.
No, mine crashed completely.
Mine also worked. Oh, never mind. No, I got the same error.
So it says path node is equal to blah, 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 and the error that I have is click to open the exception. It says it's exception thrown, access violation reading an empty vector, right? So So why is this the way it is, right? It says if I'm keeping node is true, then do it. Path node is this one. This is the path node up here, where I set up, notice it says here there's a number, there's my path node. And what I'm doing is it clears the nodes first. So it tries to clear the nodes first. And then what it's doing is it's adding a new path node. So here, this is the new path node. I'm allocating a new path node. And then what I'm doing is I'm going through each of the obstacles. Here's the obstacles. And I'm making a collision detection with my path node and the obstacle. That's what I'm doing. If that's true, then keep node as false. And I remove the path node that's here. So path node, notice if I open this up, it's removed, okay? And that's if I have a collision between my path node and the obstacle that's in the list. Let's make sure that I did this correctly. Path node. We did the get transform position, bool keep node for auto obstacle and end obstacles. Okay. Let's make sure that I did this right. Okay, and then I do my collision manager, and I pass in the path node and the obstacle, and then I keep node is equal to false. That's true. Oh, I got it. All right, so this part should be outside of there. So this part here should not be in here. That's my bad. That's my bad typing. Let's take that out of there. Let's put that outside of this first for loop here. There we go. That's where it should be. So this adds each of the nodes. And the problem, if I did it the other way around, is I haven't added them all yet. I haven't done collision detections for all of them. And then I want to run through each of the nodes that I kind of added in, right? So I run through each of them, add it in, make them all false if there's something that I wanted to. But if I'm keeping all the nodes, I'm running through the other loop, and if I keep the node, I add the child. And if I don't, then I remove it. Let's try that again. Sorry, my bad, it's just a typing error. All right, there we go. Now, if I was to launch it, and if I turn on grid, we have a problem. And the problem is there is this problem right here. So why is this happening? If I move it, by the way, look, if I move it around, each of these obstacles, the offset moves along with it. So why is this happening like this? To know this, there's an offset. It's clearly there's an offset, all right? But to understand how this works is, have you guys ever coded in Unity before? Well, if you ever code, you were adding in a collider, a collision system, right? But my collision system, remember each of my objects are centered. They're in the middle. So what I'm doing is I'm casting out a box to overlap from the middle of my object. That's my AABB check. I can't do that. I need to pass in, it can't be from the middle of my object. It has to be offset. Okay, does that make sense? So I need to change the collision manager for me to do that. Let me go back and show you this. Yeah. Pathnode.cpp?
For some reason, I don't know what I did, but whenever I turned the grid on, it's like offsetter on mine, so I think I just where I'm drawing it.
That's your build grid, I think. Yeah. So if you go to your build grid, that's up here. That's this part. This part right here. You might have something wrong here. And what I'll do is I'll just split this over two lines, and hopefully that'll help you see it more clearly. Does yours look like mine? Because that's the position. Also check the offset and the tile size and all that stuff here. That could also be an issue. You could have a typo somewhere. Like multiply by 5 instead of 0.5.
Oh, this one is times, it's 0.5.
0.5, yeah. Okay, so so now that we have that, we should modify the collision manager. So I'm going to go to my Solution Explorer, and I'm going to go to Managers. I'm going to go to the Collision Manager. I'm just going to pull this open so I can see it. Here's my collision manager.h, and you can see that I have one AAB function, AABB check. Here's my AABB check. I pass in object 1 and object 2. That's the only type I have, right? And if I go to that, go to definition, what the AABB check does is it starts calculating the position 1 and position 2 from the position of the objects. However, we know, you and I know, that the object that is given this thing is centered. And because the object is centered, we have to march back, we have to offset it. So the AABB check is actually wrong, right? Now there's a couple ways to do that. We can turn on and turn off, centered or not centered. But here this is clearly wrong for the object itself. And to show you this, to show you what this looks like, if I go to the placing.cpp really quickly, and if I march up to the draw function, let's go to the draw function. So in the draw function, underneath the draw display list, that's around line 24 in my, on my side. If I use a utility function to draw each of the obstacles colliders, we'll do a for each loop. And we'll say for every obstacle in M_P obstacles, this one, for every obstacle, let's draw a box, right? And the way that would work is I want to do a util draw rect, and I want to use the position that we had before, the position of the obstacle itself, obstacle.getTransform.position, right? And the width and the height, which is the obstacle.getWidth and the obstacle.getHeight, right? Get height. Why am I not spelling this properly? There it is. And the color. Let's make the color, well, it's green. Let's leave it at green. Okay, so if I did this, this is exactly what we're doing when we calculate the object, right? If I kind of draw, what this does is it draws the collision bounds of each obstacle. That's what this does, okay? So I'm drawing the collision boundaries. Let's see how this looks, guys. And now Kayla, what Kayla says is correct. We're going to see that things are offset. But you're actually going to visually see it. Let me show you. Look. That's what's actually happening. Notice what's happening is the box, the collision bounds are starting from the middle of the obstacle. That's incorrect. Why? Because the obstacle is centered. What we need to do is we need to shift the collision boundary to the top left corner of the obstacle. In order for me to do that, I need to modify the AABB thing. And the way it would be modified is if we did it here in the draw function, we need an offset. So if I did an auto offset, and if I said that the offset is equal to half the width and half the height, it's a GLM vec2 object, that is the get width, obstacle get width, right, multiply by 0.5, and the obstacle get height, multiply by 0.5. That's the offset function. Right? This little offset that I'm making. Oops. And this offset, what I can do, because it's a vector, I can subtract it from the starting position. This is the top left corner, remember? This position right here? I can just subtract the offset. So I can say, let's subtract offset. And when I do that, now it's going to draw everything properly. This offset is what I need to do for the collision too. I'll show you what this looks like now. Watch. So if I was to do this and just draw it, then we're going to see that the obstacle is drawing the collision boundary properly. Now look, see how it's overlaid right here? There it is. You can see there's a green kind of area around it. That's correct. And that's what I need to do for the AABB function. So this offset, this idea of an offset, is what I want to do as well from my AABB. Okay, let's go back to the collision manager and fix that. So here, in my object, because I know that they're all centered, let's take these, the AABB check function, and we're going just to copy all these things, or cut these things out. So cut, and I'm going to put these width and height calculations up here. And I'm doing that because once I have the width and the height, then I can create my offset, right? I have my width and the height of each of these objects, right? So what I can say is, I want to create an offset for point 1 and an offset for point 2. Let's do that. So I'll say const auto P1 offset is equal to a GLM vec2 object, which has my P1 width times 0.5 and my P1 height times 0.5. That's my P1 offset. That's my first point, okay, for my first object. And then let's do the same thing from my P2 offset for the other one. And instead of P1 width, we're going to say P2 width and P2 height. There we go. And what I want to do here, instead of calculating the P1 and P2 as where they start off, we're just going to subtract the offset just like we did in the drawing part. So P1 offset, P1 offset. And this will be P2 offset. Okay, there we go. And I'm saving this, and let's run this. Yeah, I'm running a little bit behind. Let's just run this and see what happens. I just reorganized it like this, by the way. You know what, why I pushed these up here? So I can use them down here. That's why I did it, instead of having to type everything again. And when I run it now, you're going to see that our grid is going to look better. Ta-da! And now, if I move these obstacles around, you should see this. Look, the grid is not being shown where the obstacles are. See? Make sense? This is it right here. This is the actual function, if you missed it. So the offset then, all it does is it marches us back and it offsets from the center. Instead of starting drawing from the center of the object, it starts at the top left corner. That's what I'm doing, right? And I have to do that. I have to march back because our position is the middle of the object. That's what position means. It's not top left. Okay. And it would be nice if, this is just going back, if we're doing this all the time, then maybe what we do is inside of the, whenever we try and calculate or draw something from the top left corner, we could pre-calculate all that stuff for my object. But I'm not going to do that here. That's a major change to my game object superclass. Okay, so can we continue?
Yes.
Okay. Let's put this up on GitHub while you're doing that. So I'm going to say git add dot git commit minus m, and we'll say completed drawing the grid git push. Okay, pretty good. So we did all this part. Now we're just doing the last part, which is the actual line of sight part. How do we do line of sight? So line of sight, going back to, we can close the collision manager now, we don't need it.
No, it's just not going to
It's crashing?
It's not crashing, it's
But warnings don't stop you from running.
I know, but they're not.
P2 redefinition, different basic types.
Did you figure it out? Okay. So while you're figuring this out, what we want to do here is check the ship line of sight is going to help us detect if we have line of sight between the spaceship and the target. And this is where we had run into problems last time. So we're going to start off with M_P Starship. And we're going to say set has line of sight. By default, we're going to set it to false. So we're going to say that, and this is the default setting. Default, no line of sight, okay? And the next piece is, what happens if the ship what's the ship to target distance? So if the ship to target distance is less than or equal to the line of sight distance. Now what line of sight distance represents is the range. That's what it is, okay? So if, again, remember what I said with Abu? I'm trying to hit Abu with my laser, but I don't have the range. It's going to stop over here. It's not going to go all the way over there. I can only go 15 feet, not 20 feet, right? That's what this is. Am I in range? Right? So the way to check this is first calculate what that is. So we're going to do a const auto, and we're going to say that ship, we'll call this ship to range, right? Ship to range. We called it, we can also call it ship to target distance, but ship to range is equal to util get closest edge, and we're going to pass in the starship. The starship get transform dot position with my target object, and the target object is going to be the target. So that's the first thing. So am I in range? All right, that's the first thing. And the way to calculate that, or to check that, is to actually do an if statement. So we'll say if ship to range, right, is less than or equal to M_P starship get line of sight distance. So if the actual range, right, is less, then we're in range. So here we're in range. We are in range, right? And we'll create a contact list now, standard vector. And the contact list is going to be all the objects that we possibly might collide with. Display object pointer. We're going to call this contact list, all right? So why am I making another vector? So what I want to do is I want to collect all the objects in the scene that are not the target. And I also want to collect the target itself. And I want to calculate to see if the target is closer to the ship than these other objects. Like I said before, I'm trying to target Abu, but there's a monitor between him and me. I don't have line of sight. If there's no monitor between him and me, I have line of sight, right? There's something in between. There's an occlusion, an obstacle, right? And then we're going to calculate that by distance. Okay. So what we want to do is we want to look inside the display list. Okay. So let's look at all the objects in the display list. So we'll say for each. And the way to do that is get display list, right? And this will be the, we'll call this for every contact. So for every contact, or we can also call these display objects. That might be the better name, display object. For every display object in the display list, right? Then what we want to do is we want to check to see if it's a Pathnode. So is the display object the type? Is the type equal to a Pathnode? If the type is equal to a Pathnode, if that's the one we're looking at, well, we don't want to do anything. We just want to continue. Remember what continue does? Continue ignores Pathnodes. Ignore this. Ignore these, right? We don't care if we're trying to compare the Pathnode itself. We don't care about that. okay? And just in case I didn't calculate things properly, right? Because I'm gonna do a line cast, right? I also don't wanna care about my spaceship or my starship. I don't wanna care about that. So I wanna say, what about if the display object, if my display object get type, what if it's not equal to my spaceship, so M underscore P starship, it's not my starship, right? Get type, okay, if it's not that, so what this means is if the type of the display list I'm looking at, the object I'm looking at in the display list, if it's not my starship, so I don't care if I overlap with myself, because maybe I'm gonna cast a line from me to something else, and underneath that there's me. I can actually hit me as well. I want to ignore the ship itself, because otherwise I could say, oh yeah, that's what I'm colliding with first, right? Then I don't have line of sight. So it's not the starship. And the other thing I want to do is I want to say that, so that's the first type I want to check. And if the display object get type is not equal to the target object, right? If it's not equal to that. So let's do that next. So I want to say if this is true, if it's both of those are not true, so it's not the ship and it's not the other thing. Let me just put these in brackets here so I can really kind of exemplify this. All right, if it's not this, and I'll put this in here, display object get type is not equal to the target object get type. So it's not the target and it's not anything else. What am I seeing? What type is it? If it's not the target and it's not this, then it must be the obstacle. Now, this is anything else. It could be other things other than on the obstacle itself. So that's what this check does. So it's not the starship and it's not the target. If both of these are true, if it's not both of these things, right? Then what we want to do we want to check if the display object is closer to the spaceship than the target is. So check if the display object is closer to the starship than the target. Because if it's closer, we no line of sight, okay? So the way we're going to do that is actually have another thing. We'll say const auto ship to object distance is equal to util, and we'll say get closest edge between M underscore P starship get transform dot position and the display object. So what this does is it's checking to see the ship to object distance. What's the distance between me and the current display object I'm looking at? And that display object has to be one that is not the ship and is not the target. That means it must be the obstacle. Okay, that's the type. Okay, and then we can do that check. We can do the next if statement in here, which is if the ship to object distance, right, is less than or equal to the ship to range. So it's within range, and so it's inside of the range. Then what I want to do is I want to push this display object on the contact list. That's what I want to do. Okay? Now, one thing is that, and which is I want to point out, is if I do this, if I push the display object to the contact list, so I say, because remember, the target is also part of the contact list, the target object, right? So if I want to push this display object to the contact list, let's do that. So I'll say contact list, and then push back, and then display object. What I'm doing is I'm adding all the objects to it. That's what I'm doing. Okay? So those are all the obstacles that I'm adding. And then to calculate if I have, and it's kind of tough to see this right now because I'm kind of outside the if statement, and I'm outside that if statement, and I'm outside that for loop. I need to be within range, and this is where I'm going to calculate the distance. I'm going to say const auto has line of sight. Then we're going to make a new one, which is we're going to use the collision manager for this. Hey, collision manager, we're going to calculate, we're going to do a line of sight check. Line of sight check takes a couple of things. The agent that I want to check with, which is the ship, the endpoint that I'm checking with, which is how the distance where I'm, the actual distance of the object that I'm casting, the line that I'm casting, which is m_p starship dot get transform dot position, and then plus m_p starship dot get current direction multiplied by m_p starship get line of sight distance. And that gives me the next one. And then the next item is I want to pass in the contact list, so that has to be passed in. And finally, the target object. So that is my calculation to see if I have line of sight. And what I want to do is if I have line of sight, I'm going to say, hey, ship, m_p starship. Then I want to set has line of sight to my has whatever that returned. Okay, so that is the entire function. There's issues with this one, and we talked about this last time, and we'll go through it. There's ways of fixing it, and I have a couple of ideas, but first, let's see what happens here. And the other idea I have is I want to just check, just really briefly before I move on, if my previous version was like this one. So I'm just going to go back to my previous version just for my checking. In the winter, I have winter labs that we did. They're slightly different than these ones because we always try and move the needle, if you will. We want to move the needle forward. And my previous lab 6.1, if I'm not wrong, inside of my play scene, I just want to do a quick check because this was the issue that I had last time. And this is the entire function. And I think the only reason why I'm looking at it differently is because I'm not using AABB check with buffer. I'm okay with that. That's for my build grid. I don't care about that. That worked fine. But somewhere or another, we didn't add push back. Yeah, something or another is wrong with this. And I just wanted to check the line of sight check. Just what happens is the great thing about GitHub is that it gives us the ability to go and check some of this stuff in Collision Manager. Just one sec. I just want to check GitHub one more second, and then we'll try it out. I don't think it's going to work for the same reasons that it didn't work for the last class, which means I'll produce an update for you guys later on today or tomorrow. And here it is. So I think it's the same. Target offset, line rec check, line of sight check. Huh. Is this different? Let's see. I'm just going to keep this up for a second, and I wonder if that is the problem, that I could have put that different. Let me do that line of sight check. I'm just curious to see if it's different. Go to definition. It's very different. Look at that. It's totally different. That's the problem. So that is my bad. I will update that. There's the line of sight check. Look at that. Line of sight check is so simple compared to what I had there. So this part is what it's got to be. I knew something was wrong. I was like, no, I'm doing everything right. It's just that the line of sight check is totally different. So I'm just going to replace this, and I'll try it, and then I'll give you an answer in a second, guys. I'm just going to make sure that this is correct. Yeah, I knew something was wrong. And then I was busting my brains and trying to figure out what the problem is, but of course, it's not me. So this is get transform position. This is get width. Just one sec. And I'll give you this code. I'll put it up on, you guys are on Discord, right? I'll drop it on Discord so you guys have it. Because that's the issue. It was just a piece of code that I wrote. We changed it last time, and I didn't change it in your functions. It's okay. At least I found what the issue is. Because I was looking at it going like, what is this problem? Why is it not working when it worked before? And of course, it's just me not typing things out. Okay. Okay, let's see if this will work. I'm just going to take this line of sight check. Here we go. And on Discord, that's under our GBC programming. I'm going to put it under, where should I put it? Course related. Let's make a new section. We'll call this game 3001. There we go. And we'll just put it in there. We'll say that's the proper collision check. Okay, grab that from Discord. Does that help? Okay. All right, so if I was to run this now, and if we did everything properly with that little change, let's see if this does a better job. So, okay, a couple things. So first, let's toggle the grid on so we can see it. If I move my ship closer, even if I move my ship closer to the target position, we're in range, but because this thing is occluding, it's bad. If I move this away, we should see, oops, the wrong one, then we should see it become fully in line of sight. Now it's not working, but that is just, so this is actually should turn on now. That didn't quite work either. There's something else missing, is what I'm saying. Line of sight check is what we're doing, and but that's kind of what it should do. It should kind of turn green when we have a line of sight. So that wasn't it. Huh. Let's see. Line of sight check. Passing the agent, the endpoint, and all that kind of stuff. Yes. And then what we do is for each object in objects, if the line rec check between the start point, which is the agent transform position, that's the middle of the agent, and the endpoint, which is the line end, and the rect start, which is the object get transformed to position minus the option. Oh, see, this is, I've added in the offset here. I wonder if I just take that away because I added it in. What did it say in my, I'm just curious. I'm just going to go back online. One sec, guys. And I want, so we can figure this off and we can go home. I'm just curious to see if my AABB check had that offset in already. Because it's an AABB check that we have to do. Yeah, see? So I kind of did that here anyway. I have another check for this. That's weird. No, it looks pretty good actually. It looks pretty good. So yeah, I'm not sure, because I mean I copied it word for word. So, you know, the only thing I can think of, I'm just going to go back to checking it for a second. There is an issue here. Oh, I know why. We didn't do the line of sight check. That's what we didn't do, and that has to be done in the update function. So let's go to the update function. And let's put that line in there, because otherwise we're not checking. Let's do that. So that should fix the problem, I'm hoping. So in the placing.cpp, we're going to hit the update function. Here it is. And in the update function, we're not just going to update the display list, but we're also going to check to see if we have line of sight. Check ship line of sight, and we're going to pass in m_p target. There it is. And now if we do that and press play, hopefully we'll get line of sight happening with all of those things. So again, what we want to do is we want to put the grid on so we can see it. We can move this object away here, move the ship closer, and we're good. Look at that. It's pretty accurate. Look how accurate it is. Right? So pretty good in terms of you know, our little way of doing it. Look at that. Even if we kind of go over here and search, we're pretty good. If I move it to the left and we kind of do one of these, you can see that it kind of works with all that stuff already. This is what you can get. Is that how it's working for you? Okay. I'll check you in a second. I just want to end this off, so I want to end the recording and then I'll put this up later on. So again, what we wanted to do today we accomplished, and which is I wanted to show you how to do line of sight. Line of sight, just as an overview, is if I have anything that's between, if I cast a ray, and if I think about casting a ray, it's just a line. I'm doing a line intersection test. I'm taking a line segment and I'm overlapping it with something else. And if the thing I'm overlapping with, the list of things I'm overlapping with, if they're closer to me than the target, that means I do not have line of sight. That's how it works. If the target that I'm looking at is closer to me than anything else, then I have line of sight. That's what line of sight is. But you need to pick your target. So right now there's only one target, the target. But if I had multiple targets, then I would have any one of those things to provide line of sight. Okay, so that is kind of the line of sight thing. That's what I wanted to cover today. I'm going to just update this, and I'm going to put this up on GitHub. So I'm going to do this now. Just want to say git add dot, git commit -m, and we'll say completed line of sight. And then git push. This is our first lab. One thing also that I didn't change, I just want to finish off for today, I know we're running way over time, is in the placing, if I go to the GUI the GUI function, I didn't change, if I'm not wrong, the name of my, I don't think I changed the name of my window. So that's one thing we have to do, which is the title. And I think the title that I posted here was inside of the place of the start scene here. Oops, start. And that's here where it says the title is the play scene for the GUI title. Really what this should be is Lab 6, Part 1. Okay, that's the only thing that has to change. So if I run this now, and if I look at the title of my I am GUI, it'll say Lab 6 Part 1. Okay. So we know that that's the one we're doing. Okay, so that's it for today. I'm just going to put this up on GitHub, and then I'll stop recording, and I'll take some questions, and I'll help you out with your problems. Oop. Okay, and that's it. I'll see you guys on Thursday for those people who are watching the recording.